Hello students and welcome to our today's class. In our today's class, we are going to have a continuation on the equations of straight line, whereby we are going to start and discuss a new concept. And the concept that we are going to discuss this day is on the idea of parallel lines. I know so far we have heard about the parallel lines, and I'm pretty sure you know what they mean. But if you don't, then I can have an opportunity to remind you. Parallel lines are those lines that actually they run in the same direction, and they behave in a manner that they can never meet. They run in the same direction and they can never meet. See, these lines then are known as the parallel lines. One very crucial concept about parallel lines and what makes them not to meet, it is simply because they have the same gradient. The slopeness of this line and the slopeness of this line is actually the same, and that's why they will run and they will never meet at any given point. But if, for example, we had a line that is sloping like that and another one sloping like this, we cannot call these parallel lines simply because these lines, if you extend them, at one point they are going to meet. So the slopeness of the parallel line is always equal. And I can have also an opportunity to remind you on some things that we discussed in the previous class so that it can be easy for you to grasp the concept that I'm going to put across in this particular lesson. So, in our previous lesson, we discussed about equations of straight line. And I said the equation of a straight line is normally expressed in the form of y is equals to mx plus c, where this m simply denotes the gradient. This is actually our gradient. The letter or the number that is going to be next to x is actually our gradient. And this c, I said it is the y-intercept, which simply means the point at which that particular line will cut the y-axis. So if you have the equation maybe is y is equals to 8x plus 7, it simply means that the gradient of that line is 8 and that line cuts the y-axis at the point where y is 7. So it is actually the same as this. You have got the point where y is 7 on the y-axis and that line will be running in that manner and it cuts the y-axis at the point where y is 7. So if you are given an equation like this, like y minus 2x plus 7 is equals to 0, you are told to find the gradient of this line. What you need to do is to rearrange this equation to be in the form of y is equals to mx plus c by simply making sure that you have only y on the left hand side and all the other elements are taken to the other side so that you can be able to get your gradient by having a look at the value that is going to be adjacent to x. So this one can be written as y is equals to, we take negative 2x to the other side to be positive 2x, we take 7 to the other side to be negative 7, and we can be able to note that now our gradient in this case is 2 and our y-intercept is actually negative 7. So you can be given also an equation like this, like 5x plus 7 is equals to y minus 2. And you are told, can you determine the equation of this line? What you need to do is simply make sure that you have got y on one side and all the others on the other side. So we can simply say this, that 5x plus 7, this negative 2 will come to this side to be positive 2 is equals to y. So 5x plus 9 is equals to y. So it can simply be written as y is equals to 5x plus 9. It does not have any harm. So we can be able to find that our g or gradient is actually going to be equal to 5. Having understood that, now I can go and discuss more about what we want to discuss today. And the discussion is like this. If parallel lines have the same gradient, then if you are given the gradient of one line, that gradient is going to be the same as the gradient of the other line. So if, for example, you are told that a parallel line or two parallel lines, two parallel lines, let me write it correctly. The question is this: two parallel lines are given are given are given as R1 with the equation y is equals to 2x plus 4, and R2 that passes through point 1,8. The question is, find the equation of line R2. Find the equation of line 2. So you are given two parallel lines are given as a R1 with the equation this and R2 that passes through point this. Now you are asked, can you determine the equation of R2? This one now, you need to note that if these two lines are parallel, the gradient for R1 is actually 2. It is our M here. Therefore, gradient for R2 should also be 2 because these two lines are parallel. Once you have got the gradient and you have got one point, you can be able to determine the equation from what we discussed yesterday. So we have got the point 1,8 and we assume another point xy. So if we do change in y over change in x, which is y minus 8 over x minus 1, they should give us 2. Therefore, this is the same as 2 over 1. 1 will multiply here to have y minus 8 is equals to 2. If it multiplies here, it's going to be 2 into x minus 1, which is y minus 8 is equals to 2x minus 2, which is now y is equals to 2x minus 2 minus plus 8, because this one will go to the other side to be positive. So y is equals to 2x plus 6. And actually, that is how you determine that. So you need to borrow the idea that parallel lines have got the same gradient. If you have been given the gradient of one, that is exactly the gradient for the other. And if you have been given 1 point, then you can do change in y over change in x, having assumed 1 point first. And then you equate with the gradient that you have determined. And then if you solve that particular equation, it will give you exactly the equation of that other line that you have been asked to find. So basically, that is how we do it. So the concept here that you need to remember always is that parallel lines, they have the same gradient. Thank you very much.